When you look up at the night sky, what do you see? Stars, the moon, galaxies, light, planets, movement. Maybe it feels crowded. Maybe the universe looks like a wild theater of activity. But what if I told you the universe is not full? It's not even mostly empty. It's unbelievably empty. So empty, in fact, that almost every beam of light the sun emits never touches anything. Not a planet, not a moon, not an asteroid, not even a rogue dust grain. It just flies straight into darkness. Forever. We talk about the vacuum of space. But vacuum doesn't do it justice. This isn't just emptiness. This is emptiness on a scale we're not wired to understand. So today on Brain Static, we're going to explore what empty really means, from sunbeams to supervoids. And we might just discover that nothingness might be the universe's greatest feature. Let's start with a familiar star, the sun. It blasts out about 380 septillion watts of energy every second. That's more energy than our entire civilization has ever used, multiplied trillions of times. But here's the cosmic punchline. Almost none of that energy touches anything. By some estimates, 98.5% of sunlight sails through space forever. It doesn't hit Earth. Doesn't hit Mercury, the nearest planet to the sun. Not even a random asteroid drifting in the dark asteroid belt. Imagine lighting 1 billion torches, and only 2 ever find someone to warm. That's our solar system. And when that light escapes the solar system's orbit and the Kuiper belt where there are dwarf planets like Pluto, Eris, and Orcus, it enters interstellar space. The vast, chilling ocean between stars. An ocean so empty, it makes our solar system look crowded. Movies love to show the asteroid belt as a death trap. A dense swarm of tumbling rocks, smashing and dodging like a cosmic car chase. But in real life, you could fly a spaceship through it blindfolded, and have a near-zero chance of hitting anything. Actually, the average distance between asteroids is nearly 1 million kilometers. That's about 3 times the distance between Earth and the Moon. There are millions of rocks in the asteroid belt, yes. One of them, Ceres, is so large that it's considered a dwarf planet. But they're spread over a space so vast, it would take light minutes to cross it. To collide, a typical 1-kilometer asteroid might hit another object once every few billion years. Our solar system isn't a chaotic maze, as shown in movies like Star Wars. Let's leave our solar system behind. No planets, no comets, just darkness, and the occasional speck of a distant star. The closest star to us, Proxima Centauri, is about 4.24 light-years away. That's nearly 40 trillion kilometers. To compare, the distance from Earth to Jupiter is only about 628 million kilometers. So the space between stars, it's about 9,000 times wider than the width of our solar system. Imagine placing a single grain of salt on the floor. Now walk 30 kilometers away and place a second one. That's how isolated stars really are. Space between them isn't just empty, it's unfathomably empty. In fact, the average density of matter in the interstellar medium is just 1 atom per cubic centimeter. That's like stretching a single breath across a stadium. For all its stars, space is more like a gallery. Vast, quiet, and sparsely decorated. Now here's a paradox. The Milky Way and the Andromeda Galaxy are headed straight for each other. At a speed of about 110 kilometers per second, they'll crash in about 4 to 5 billion years. That sounds like chaos, but it'll be a silent ballet. Both galaxies combined contain over 1.5 trillion stars. But the distance between stars is so vast that statistically, almost no stars will actually collide. Not 1, not 2, 0. They'll swirl around each other, merge gravitationally, and become something new, a giant elliptical galaxy. But for most star systems inside them, life will go on, uninterrupted. Even in a galactic train wreck, space stays, painfully, majestically, empty. You've heard of black holes. They are regions of space where gravity is so strong that nothing can escape them, not even light. But have you heard of cosmic voids? These are regions of the universe where there's almost nothing at all. No stars, no galaxies, no light, just black. One of the largest is the Boötes void, a terrifying name and an even more terrifying fact. It spans about 330 million light-years across and contains just 60 galaxies when it should contain over 2,000. To travel across it at the speed of light would still take longer than humans have existed. If you were inside the Boötes void and looked in every direction, you might see nothing. No stars, no galaxies, just night. And this isn't rare. Voids make up about 80% of the universe's volume. The entire cosmic web, that beautiful sponge-like structure, is mostly holes. It's not that matter isn't out there. It's just spread so thin, You could wait a billion years and still never see a neighbor. So far, we've painted a picture of a universe made of nothing. Sunlight that misses everything. Asteroids light-years apart. Galaxies colliding in silence. But here's the twist. Even the emptiest part of the universe still isn't truly empty. According to quantum physics, a perfect vacuum doesn't and maybe can't exist. What we think of as empty is actually full of invisible fields. Quantum fields. They permeate all of space. Even in a vacuum, with all the air sucked out, all matter gone, particles still blink into and out of existence. These are called virtual particles. They live and die in fractions of a second. A dance of possibility. A foam of nothingness trying to become something. This is called the quantum vacuum, and it's not just theoretical. It's real. We've even measured its effects. In the Casimir effect, two metal plates placed extremely close in a vacuum will feel a force pulling them together. Not because of gravity, but because of the quantum fields between them. Space, truly empty space, pushes and pulls. It has energy, mass, potential. So even the deepest part of space isn't really nothing. It's a restless nothing. Humans have tried to make perfect vacuums, and we've come close. Some of our cleanest vacuum chambers have less than 1 particle per cubic centimeter. Incredibly empty, but not perfect. Even in the Large Hadron Collider, which requires near-perfect vacuum for particles to travel, we can't remove everything. Residual gas, background radiation, quantum fluctuations, emptiness, always resists. Why? Because space is not a blank page. It's a stage already set for particles, waves, and energy to exist. You can remove matter, you can remove light, but space itself holds structure. It's never truly at zero. So why does the universe prefer emptiness? Why, when we zoom out, do we find more dark than light? The answer may be energy, stability, and the strange rules of physics. Dense things collapse, light things explode, but empty space? It's stable, quiet, and vast emptiness might actually fuel the universe's expansion. Think about dark energy, the force that's accelerating the expansion of space. It's not coming from galaxies or stars. It's coming from the vacuum itself. The nothing between galaxies might contain the very engine of everything. Without emptiness, there's no room for galaxies to grow, no backdrop for stars to shine, no silence to make the cosmic music resonate. The universe doesn't just tolerate emptiness. It requires it. So how empty is space? Really? Sunlight races across it, almost never touching a thing. Asteroids drift for eternity, alone. Stars are separated by oceans of dark. Galaxies collide, but barely touch. Supervoids stretch 300 million light-years with no welcome sign. And even in the quietest vacuum, something still stirs. Maybe the universe is built not on what is, but on what isn't. On gaps, on space, on silence. This has been Brain Static. Stay curious. And remember, sometimes the most profound truths hide in the silence between stars.